Let's suppose we have a curve in space going from the point R of A to the point R of B. Now imagine that this curve is actually a length of string stretched out in space, and we want to know what is the length of the string. Well, it doesn't sound very advanced to talk about lengths of strings, so what we do is we call this arc length. So if we look at the arc length from R of A to R of B, it turns out that it's the integral of the magnitude of R prime from A to B. Now if we just replace the point B with T, we can compute the length along the curve from the beginning to any point along the curve. It's the same formula, just with a B replaced by T. And we call this quantity S of T. And sometimes it's referred to as the arc length parameter. So along any point along the curve, you can compute the length from the beginning to that point. And that's S. Well, S of T is defined as the integral of the magnitude of R prime. That means that by the fundamental theorem of calculus, ds dt is the magnitude of R prime at t. Right? The derivative of an integral is the thing itself. Well, that's really interesting because that quantity has an interpretation if t is time. So if t is time, then R prime, the vector, which we can call v of t, is really the velocity of the motion. So you imagine there's a particle moving with this function of time. Then R prime is the velocity, and R double prime, which we can write as A of t, is the acceleration. Now, both velocity and acceleration are vectors. But the magnitude of v, which is the same as the magnitude of R prime, is the speed, and that's the scalar. So really the derivative of the arc length is the speed.